Okay, hello guys, welcome to today's Foreman deployment design deep dive. We'd like to guide you through the work we've done so far towards enabling multi-host orchestration in Foreman. I will try to present you all the stuff, and would like to ask Peter if he can add some more info when I forget to mention anything. So first, I would like to go through the goals of this feature. Then I will show you how we solved it in the design, and at the very end, I've prepared a use case how to install or deploy a satellite 6 with a few capsules using this design, which I guess will be followed by discussion, hopefully. So goals of the feature are to allow defining multi-host provisioning, configuration, and orchestration. We wanted to define the deployments independently of a Foreman instance to enable sharing of the definitions, and ideally at the very end to allow for building a database of such prescriptions, which can be shared across people. Another important feature we wanted to achieve is enable for one-click deployments based on saved pre-configurations, which would enable users to clone existing deployments easily. The main overall deployment workflow, as we think of it, is that first someone creates a deployment description. We call it a stack, which would be saved somewhere locally in a file, and it's then imported into a Foreman instance. Foreman saves it into a database and allows some operations on it. Here it is the point where it can be exported from other instance and shared across them. When we have the prescriptions saved at Foreman, we can configure it. At this step, we map the instance specifics on the items from the prescription, and the result of this operation is configured deployment, which is ready to start. And when it's configured, user can hit the run button, and the system starts provisioning the machines and deploying all the pieces. I'd like to talk a bit more about these specific items now. So the main prescription is called stack. It describes the deployment process. We got to a very task-centric design where stack consists of multiple tasks that are dependent on each other. And this task-centric approach helps us to allow for integration of additional tools and seems to be very universal. Example tasks, before I get deeper, can be Puppet Run, which executes Puppet Run on a host or provision a host, or take subnet. We tend to follow a convention to call tasks that create or select some Foreman entity as take tasks. So later in the presentation, you will see take host group, and so on. And it will always mean that the user can either select an existing item or create a new one in the configuration phase. So let's have a look closer at the tasks. Tasks will be modeled as extended time flow actions. Time flow is a workflow engine that was written mainly for means of catalog orchestration. Let me check. Let me check a question on the IRC. What asks at the IRC, what's the object about stack? The thing that define the app you want to deploy. So the terminology that we use is that stack is the main prescription and deployment is instance of the stack. Basically, stack plus configuration is deployment. Am I right, Peter?
Sorry, I couldn't find the unmute button. Just one note, you can also deploy the configuration multiple times. So it's basically the instance of a deployment requires a stack with a certain configuration, and you can do it multiple times. So deployment is third entity in this scenario.
Yep. So back to the tasks. Each task have defined all possible inputs and results that it can produce, and it is used for calculating dependencies between the tasks. So later the time flow can calculate the order in which it is executed and can use concurrency. The stack that uses a task gives it a name and a description, which is used later in the configuration phase to be presented to the user and give it some idea what this item is for. But the task doesn't need to define all the inputs, and some can be omitted. So I will talk about it on the next slide. You've got an example about such task here. This is take subnet, as I've mentioned, that take tasks either create a new item or use existing one. If an existing one is used, then we would perform validations on it, whether it matches the expectations that are set in the stack. So here, take subnet task have following input. It can take a name of the subnet, network address, and network mask, and result is always a instance of a subnet. How it's used, you will see later. Do you want to add anything more to tasks, Peter, please?
Nothing comes to mind, thanks.
So let's have a closer look on the stack definition. I mentioned that it defines tasks and their inputs. We want it to be defined in some other format than in plain code, so that it can be easily transferred somewhere else. So far, it seems that plain YAML will work fine, and I've created an example of such stack here. In the example, you've got one database server host group, which is of type take host group. I disallowed selection of existing host group here, so it will be always created, and in our case it will be just empty host group named DB servers. And then there is another DB host task of type take host, and it defines several inputs. Input can be either a hard-coded value, as we can see, for example, here in the comment, or it can be input that is configured by a user in the configuration phase. Here it is, for example, the count, which defines how many hosts of such type will be deployed. You can see that it is possible to specify type input. You always need to set some constraint there, the type constraint, and some validation, which is here that minimal value is 1. Another possibility is to set a reference to output of another task, and this is how users can define order of the tasks. We can see it here that the host group is type reference and is referenced to object DB server host group and takes its result. One more possibility that is not mentioned in the list above is using templates. This can be handy for creating prescriptions for values when, for example, in case of the host, you can create multiple instances of this host, and you want to have them. You want to have unique names for each of them. I just saw that there was another question. Let me check it. Brad is asking whether a stack can have multiple host groups. Yes, it can have multiple host groups, and it's in this design, users are not forced to use a host group per host as it was in the original one. We still think that it's a good habit, but it's completely up to the creator of the stack how many host group it uses. Peter, do you want to add anything?
No, please continue. Thanks.
Okay. So when the stack is defined and imported, we can map it on the instance-specific configuration and start the deployment process. The user interface or approach that we take to the user interface is still not decided. There are 2 of them actually so far that we've discussed. The first one is what I have here on the slide, and it is that the stack defines a limit available configuration for the user. We designed it with good user experience in mind, and we wanted to avoid users to enter disallowed values into the configuration. And the process of building the UI starts with collecting the tasks that require any kind of input and rendering UI for them. The example of such UIs is in the frame below. The provisioning subnet is take subnet task, and the frame below is for hosts, where you can select number of hosts and possibly enter a name template. And we always want to allow users to create a new items from this UI. Each task would define its own configuration UI, which can be generated automatically for the simpler ones, but we want to allow the full power of custom UI for the more complicated ones. Before the configuration is saved, the input is validated, and the validation is performed on both the single values and the relationships between them. Another approach to the UI is what Shim mentioned on the mailing list today, and it's to present the full UI forms of the records as we know it from the simple format. So we still need to discuss this and find a good balance between repeating ourselves in writing a new views and making users' life easier enough. When a task is when a deployment is configured, it can be we can start the deployment process where all the tasks are ordered and processed by Dyneflow. We can benefit from reusing Dyneflow's ability to evaluate tasks concurrently and calculate the possibilities of concurrent evaluation. So we get all this for free, plus progress tracking and the power of Dyneflow console. I've mentioned that the ordering is based on task input and results. This brings us to a problem that sometimes you need to order actions that don't directly depend on each other in terms of the data they use. For that, we designed an dummy input field after that can take a reference to another task and ensures that the tasks are executed one after another. You can see in an example that here in the second puppet run, the after field is a reference to the first one. One feature we would like to have is stored configurations. It will either keep the instance-specific values separate from the stack, but it will allow for easy cloning of existing deployments, and even more, it will allow us to create or store pre-created configurations. It can be either partial configurations or full configurations, and users then can select stored config when he starts the deployment creation process, and it can result to even one-click deployments when it's fully configured. So it could be good for example, RECR projects like that. Let me check the IRC again. Peter, can you please repeat the question and answer it live for everybody?
Okay, so there was a question on ArrayCI about how this works in relation to ArrayCI. So the assumption is that ArrayCI will define the YAML files, meaning the stack definitions, and it will define what configuration needs to be supplied when user is actually deploying the stacks, meaning the ref config. So this cloud forms and other pieces of ArrayCI. So the custom ArrayCI UI can just provide the configuration piece, and then after that it's provided, it can trigger the deployment.
Thank you. Another chapter, important one, is extensibility. Foreman deployments will be extensible via plugins, as usual in Foreman. Plugins can define their own deployment tasks, but they can also add properties to existing tasks. And the good thing is that with the task approach, we don't need to be limited on the Foreman and can create extensions and integrations of third-party systems like email notifications, or bring approvals into the process, or integrate any kind of system where, for example, REST calls. The one we want to integrate from the very beginning is, of course, catalog, and it will be integrated via activation keys that are defined on take host actions and take host task and take host group task. And possibly we can create a custom task take activation key that would allow selecting an activation key and applying it on the two on the line above. Important feature is editing infrastructure that is already deployed. For example, you might want to add more capsules into a deployed satellite infrastructure. It can be done automatically in most cases with our design, but we believe that it's a good approach to let the users to define special processes or special stacks for such operations, which will be handled via deployments too. I will show how to do it in the example later. I would actually some stack for adding more capsules. So far it was features that we want in from the very beginning, and now there are some features that can be added later to give stacks more power. We would like to have the ability to create composed stacks that can be composed of another stacks that already exist, and the encapsulating stack could pair inputs and the results of the other used stacks, and could benefit from reusing the work that somebody has already done. Another feature would be stack inheritance that would allow for defining common behavior in parent stacks, and the children could only add more tasks or edit and couple input and the result of the parent. And the last important feature is abstract stacks, which would allow for defining an abstraction that can be replaced by a concrete stack just before the configuration phase starts. An example could be a database stack that can be replaced by PostgreSQL or MySQL stack, and it will make the stack definition more flexible. So let's have a look at the example.
Sorry for interruption. There were a few more questions on RAC. Do you want to answer them, or should I?
I haven't read them, so if you can do it,
okay,
please.
So the first was how does error handling goes here with such a complicated operation? So basically, since all this process is the Dyneflow tasks, or Dyneflow actions, the Dyneflow is already handling that, so it records any failures happening in the process, and you can inspect that any error and the logs in the Dyneflow console. And if you are able to fix it, you can even resume the process and stuff like that. And there was also another question about the Kata integration. Brett mentioned that the activation keys may not be enough. We've tried to simplify it. So yeah, as we've mentioned, I think it should be quite extensible. So any plugin can add custom tasks for any purpose they need. So in this case, we can add some content management tasks which will configure the host group or host, so for some specific content view or something like that. So that that should be all possible. And I think that's all.
Thank you, Peter. Okay, so let's have a look at the example. It's a satellite 6 deployment, and I've split the problem into 3 subproblems. First is provision and configure a satellite 6 machine. The second is provision and configure capsules. And the last piece is to couple them together. Let's start with the first one. It consists basically of 3 steps. To provision the machine, to get content for the machine, and install satellite 6 on that. It would be modeled by five tasks. The main one is take host, that defines the host machine for the satellite. It takes input from other 2 ones. First one is provisioning subnet, second one is satellite operating system. Provisioning subnet is there just to enable users to select some subnet it will be provisioned on, and the take operating system tasks limits the operating system family on RHEL and limits the version on 6.5 or higher. In this very simplified example, we have the name as user's input, and we let the users to select an activation key. Count for the satellite master server is always 1. When such host is created in Foreman, we will pass the output of the action of the task to the provision host tasks, and it will provision the machine. And the very last step is to install the satellite, and we can do it via remote execution. We run the catalog installer with some parameters there. The remote execution task is quite complicated one, and I've discussed it with Ivan Nechas, and it seems that some efforts of deployments and remote executions are overlapping, and we're working together to remove duplicities and use and build the code on a common ground. So this is the YAML prescription for the stack. It consists of the provisioning subnet, satellite OS. Here is the satellite machine that is connected with the operating system and the subnet, and then the remote execution provision host. Second piece is provisioning capsules. The start of the process is similar to creating satellite master. So we select some subnet, limit the operating system, and create the host for that. There's one difference, that we allow users to specify count of such machines, and basically from this task on, everything would be run multiple times based on the count that user inputs here. Name for the capsule is templated to capsule dash and index of the capsule. The rest is same, and then the host is provisioned, and here we've got take host task for selecting satellite master for the capsule. So if we deployed this capsule stack separately, users would need to select some existing host as the master satellite for the capsule. We will see how we use this input later when we join both stacks together. Then remote execution tasks follows, that generates certificates on the satellite master and distributes them to the capsules. And the very last step is to install capsule using certificates and OAuth keys and secrets from satellite master machine. Here is example YAML definition for that. It's very same, I guess, that I won't spend much time with it here. You can have a look at it later in the slides. The interesting part comes now. We can use the both substacks and encapsulate them by a new stack that can create the whole satellite infrastructure. We will edit some of the links in the or between the substacks in the encapsulating stack, and we will set the subnet of capsule providing subnet to a provision subnet of the satellites stack. We will join the activation keys so that it has the same content, and we provide the satellite instance from the first stack to the capsule satellite machine. There was some question on IRC again. She was mentioning that the remote execution could be replaced by Puppet classes. It could in some cases, and I will get to it. I've got it on the next slide, or in 3 slides we will get to it, and I will mention how we could do it with Puppet. So here is how the encapsulating stack would look like. It uses satellite and capsule substacks, and it can modify the links between them. So from capsule stack, you update the satellite machine tasks and set the activation key to reference from the satellite stack's satellite machine, and the rest works similarly. And as I've mentioned, when this deployment is done, and a user would want to add more capsules, he could do it by running capsule stack again later. The Puppet integration that Shim mentioned is done via tail hosts that have input fields for Puppet classes and parameters, and we have additional tasks for running Puppet in the deployment process, and it's Puppet run and enable or disable Puppet. We were thinking about running Puppet automatically for cases where users set some classes, but then we decided to leave it all under control of the stack writer. But we can provide some validation checks if Puppet run task is present when you assign some classes to a host in the stack or to a host group in the stack to prevent users from doing such mistakes and to provide better user experience. Similar approach would be taken for other configuration tools as we plan to integrate more of them in the future. So I guess that was all from my side. Peter, do you want to add anything, please?
Nothing comes to mind right now, thanks.
Can you, Peter, please wrap up Lukáš's note from the IRC?
Right. So Lukáš asked or mentioned that the capsule can be sometimes provisioned on a different provisioning network than the satellite itself. So in that case, the connection between the stack definitions would be defined differently. This was just a simple case, so it would be easier to understand in the presentation, but you can also change it and define two independent configuration points or the inputs, and it can be configured on two different provisioning networks, the satellite and capsule. So it should not be a problem.
Okay, so if we don't have any other questions, I will thank you for your attention, and we can discuss the design on the mailing list.
Thanks so much for the presentation.
Thank you.